Hello students, today we will study about internal impedance of voltage source in basic electricity topic. First we will study the internal impedance of a source. Okay, so first of all we should know the difference between EMF of a cell and potential difference. EMF of a cell and potential difference. So the potential difference is always less than EMF of a cell. The potential difference is always less than EMF of any voltage source. So this AC source has some internal resistance, and this internal resistance of AC source is called as impedance. It is called as impedance. Every source of electricity has some internal resistance, and it is due to the uh, resistance of electrolyte used in case of cell. In cell there is electrolyte, and this electrolyte has some internal resistance. Okay, then the resistance of copper wire used for generators, it has some internal resistance. Then the equipment impedance of electronic circuit, for example rectifier circuit. This rectifier circuit, it is an electronic circuit. It has also some internal resistance. Okay, so uh, consider a DC source of 1.5 volt cell, and if it is open circuited or if it is not connected to the output resistance or to the load resistance, that is if the terminals or poles, positive and negative terminals of this cell is open, then we get the terminal voltage 1.5 volt. We get exactly 1.5 volt. If load is not connected across its output terminals, then we get exactly 1.5 volt. That is the potential difference. Potential difference is 1.5 volt. Now if this cell having internal resistance 5 ohm, if it is connected to load resistance of 10 ohm, then we do not get exactly 1.5 volt. This is because this cell has internal resistance and it is 5 ohm. Okay, it is 5 ohm. Therefore, this internal resistance 5 ohm and load resistance 10 ohm, these resistors come in series. Therefore, the total resistance becomes 10 plus 5, that is 15 ohm. Then first of all we will calculate the current flowing through this circuit. So current according to Ohm's law, current I is equal to E upon R plus R, or I is equal to V upon R. So V means EMF, E, so E divided by R means total resistance, R plus R, because these two resistors are in series. Therefore 1.5 divided by 5 plus 10, that is 15. So 1.5 divided by 15, that is equal to 1.1 ampere. That is equal to 1 upon 10, 15 divided by 150. 15 upon 150, that is 1 upon 10, that is 0.1 ampere. This much amount of current will flow in this circuit. Now, so the voltage across this internal resistance R, that is equal to I into R, that is I means 0.1 and R means 5 ohm. So 0.1 into 5, that is equal to 0.5 volt. So this 0.5 volt will drop this voltage, voltage 0.5, it will drop across this R. Okay, now the EMF of a cell is 1.5. So 1.5 minus 0.5, that is 1 volt will drop across this load resistance. So we will get the terminal voltage or potential difference 1 volt. Okay, 1.5 minus 0.5, or we can also calculate I into R, that is voltage across this load resistance. Voltage drop across this load resistance R, that is equal to I into capital R, that is I is 0.1 into 10, that is equal to 1 volt. So the terminal voltage or the potential difference across the output terminals phi is equal to 1 volt. So instead of 1.5 volt, we are getting here 1 volt, and it is due to the internal impedance of the source. This internal impedance here of this cell is 5 ohm. Okay, and 0.5 volt drops across this R. So we do not get 1.5 volt. So instead of 1.5 volt, we get phi is equal to 1 volt. Okay, now take one example here. Find the potential difference across the output terminals of an electronic circuit if source voltage is 10 volt and internal impedance is 20 ohm. Here the internal impedance is 20 ohm and EMF of the voltage source is 10 volt, therefore, and the load resistance is 480 ohm. So first of all, we will calculate current I is equal to E upon Zi plus ZL, that is 10 divided by 20 plus 480, that is 10 upon 500, 20 plus 480. These resistors are in series. Therefore, I is equal to 10 upon 500 into 1000. This current will be converted into milliampere. 10 upon 500 ampere means 10 upon 500 into 1000 milliampere, that is 20 milliampere, means 0.02 ampere. So voltage across the terminals or potential difference across A and B terminals, that is equal to I into ZL. So I is 0.02 and ZL is 480. So 0.02 into 480, that is equal to 9.6 volt. Okay, so instead of 10 volt, we are getting 9.6 volt. So we will stop